Any confusion?
Any problem in the first question?
Okay, Abbar, could you explain the solution? It's not easy that it's not easy in that way.
Yeah, sure. So, what we can do here is to solve these types of problems, we just have to synthesize the problem or synthesize this closed loop into smaller closed loops. So, to solve this problem, first we need to find what are these parameters based on. So, we can what we can do. So, as you can see, E will be equals to E is YSP minus Y minus 2. We'll write all these things and then we'll make this closed loop into a
Yes,
smaller closed loop like this,
Abbar,
right?
line by
Sorry.
explain line by line. So let them
Yeah,
see
sure.
what.
Yeah, sure. So to synthesize this closed loop, first we'll find out what is the value of the C. So we can write E as this YSP minus Y minus Y2 bar. Then what will be the value? So to synthesize this closed loop or to shorten this closed loop, we have to find the relation between E and P basically. To find this relation, we have to synthesize these closed loop. So the E prime can be equal to E minus the Y1 bar. Here we can see that this Y1 bar is equals to P into G star, which we already know, and Y2 bar is equals to Y1 star into e power minus theta s. And from here we know that what is the value for E. So we can write E prime equals to this. Right. Now, to synthesize this closed loop, what we can do is like if you see here, we need to find a relation between P, E, and E bar, right? Uh, if we see here, E bar is YSP minus Y plus Y2 minus Y1 bar, right? What we can do is we can join these two and connect it with it. So what we find is the relation between E bar and E is already same, which is YSP minus Y. which is here already seen, our E would change. As you only want to find the relation between y by d, the transfer function between y and d, it would be okay to synthesize this closed loop here, which is p equals to p bar into gc, and this one. Now for the inner loop, we can still synthesize this into a smaller transfer function, which is p by e, and it would be equals to gc bar. So we can replace this by a block, which is a gc bar, which would be equal to this. Now we need to find the transfer function of y and d, y by d. So it would be equal to the g into gd, which is the already formula, and multiply by the all the transfer blocks in a straight line. So it would be gc into gc star. Oh, sorry, it would be bar into g. Gc bar is the transfer block for this whole loop. Now, replacing the value for gc bar, we can find the value for y by d transfer function. So, any doubt in that?
I hope there may be some.
Sir, how did you like write this g star 1 minus e to the power minus theta s? How is it broken the inner closed loop?
Ah, apart,
Sir, you are not audible. Apart, sir.
yeah, you can speak. Hello, hello.
Yes, sir.
Yeah, you can share the screen and speak about, please. Matthew, no. Okay, so meanwhile, I will share my screen and speak a little bit. Could you see my screen?
Yes, sir.
This is nothing but an arc. Okay, so you have to look at what is that is going to E. Huh? What is that connecting between G and E prime, right? So tell me what is that connecting P and E prime? It is P times G tilde, which is Y1 tilde, correct?
So could you repeat here like not clear?
Okay, so what is that going as E prime? E prime is basically the difference between E minus Y tilde, Y1 tilde, rather, correct?
Yes, sir.
So now you have to write what is Y1 tilde. So what is Y1 tilde? So y1 tilde is p
P into
times
G star.
fine.
Yes, sir.
Now it's not yet done. So you really need to take this guy. So see now what is happening? This y1 tilde and also y1 tilde. So please look at this problem very carefully. Yeah? So this y1 tilde is operated upon e raised to minus theta s and become y2 tilde. Correct?
Yes, sir.
And this y2 tilde is become negative and it is altogether negative until here and it become once it reaches here that becomes so this whole thing become negative. Agree?
Yes, sir.
So and what is going to happen and afterwards so between this after this negative no operation happens. It is just another addition that is being added by this y1 tilde. Correct?
Can you repeat?
Okay. So look at this. Okay. So after this, when this becomes negative, so this y2 tilde is getting subtracted with y and getting and going to the comparator block of ysc right here.
Yes, sir. Yes, sir.
So then there is nothing happening. So then what is happening? There is no multiplication, nothing. Okay. It's just getting added up. What else is happening? It is just getting added up as an your y1 tilde is just getting added up in the second line. Fine.
Yes, sir.
So if you add your y2 tilde in the first block, if you add your y2 tilde in the second block, technically there is nothing is going to happen because it is just an addition term that is being used. Correct? So if there was some sort of a what we call block which is between y1 e and e1, it would have been a different case. Are you getting it? It is now just a simple addition. Any questions here at the moment? Hello.
No, sir. No, sir.
Yeah, am I
Okay.
audible?
Yeah, Abhar, you are. So please take it up.
Yeah.
I,
So
I
I
will.
guess
I will answer.
professor must have explained this, but still, what I was used to do was basically I always used to take these what is the output signal and what is the input signal separately, which is YSP minus Y. Now the remaining signal is Y2 minus Y1, right? And we have to find a small block between P and E, right? So we have to find something with this E prime. Now we know that E prime is equals to this, which is one is output signal and one is input signal. We cannot do anything with that. The remaining is Y2 minus Y1 bar. And we know that Y2 depends on G star and Y1 depends on G star and Y2 can be written as P G star E power minus theta s. So Y2 or Y1 minus Y2 can be written as this thing. So whenever you find these types of formula, you can synthesize this whole block like this, right? Because ultimately you have to find the transfer coefficient between the output and the disturbance, the y by d. So synthesizing this would be a more simpler method to find this type of thing. So this was my method I was used to doing.
Okay. Hold on. Hold. Just
Yeah.
go. Let me add this more onto that. Yeah. So keep it there. So see. So what I was trying to them is that so this y2 tilde because since it is just getting an addition, you can either add at the comparator 1 or comparator 2. So at the moment it is added to comparator 2. That's why it is making two blocks. Correct? Any questions? Anyone?
No, sir. No, sir. I understood.
So now, okay, so now if you want me to add it to the comparator 1, sorry, comparator 2, correct? You can tap that Y2 tilde and of course connect it to comparator 2, but you have to make sure that you would have now two contributions, what Y1 tilde and Y2 tilde, correct?
Yes, sir.
Y1 already going there. Y2 tilde, now what we are going to do is you are fragmenting from the comparator 1 and trying to connect it to comparator 2. So Y1 tilde stays as it is. Okay, so now this new Y2 tilde, okay, we have to write that as a, because output, so Y1 tilde is also connected with Y1 tilde is, so see if you look at, so now if you are connecting to the second comparator, the output of that transfer function for that is P. So now you have to write Y2 tilde as a function of P, correct? So then you can connect it back. How do you write that now? Y2 tilde is Y1 tilde times e raised to minus theta. While what is Y1? Y1 is P times theta. Is that correct now?
Yes, sir.
So now what you really need, Y1 tilde minus Y2 tilde, right? So Y1 is P times G star, Y2 tilde is P times G star into e raised to minus theta. If you take up G tilde common out, 1 minus, sorry, if you take G tilde star common out, it would be 1 minus e raised to minus theta. Is it making sense now?
Yes, sir. Yes, sir. I can also put all these values in E prime and get it as function of P.
That is also possible, but this is a similar way. So thanks, Papa. And any others, if you have any doubt on the simplification? So the key aspect generally in the feedback loop, it would be a smooth feedback loop. There won't be any comparator in the feedback loop technically in most of the standard cases. But what is the prime problem that we have seen? It is the addition of this comparator in the feedback loop, which is non-standard. So first thing that we have to remove is this comparator in the feedback loop, where it is y tilde getting subtracted from y, because that is not in the standard form, because y is going back and getting connected to ys2 is the standard form. Okay, so you are your first and how to yeah how to take care that only taking y tilde back to the main loop without touching the main feedback loop. And you can do that because there is no transfer function operating between E and E prime. It is just the addition. So you can add it anywhere. So once you add it back to the line of the second comparator, okay, you would have to, you have to, it should be the y1 minus, so as it is written, it would be y1 minus y2 tilde, and y1 tilde is 2 times g prime star, and y2 tilde is e raised to minus theta times y1 tilde, and y1 tilde is again 2 times g. So when you just write it, it would become that the clustered loop goes out of the system. Okay, so then I think it is quite standard as Abar mentioned now. So the inside loop, you can calculate the overall transfer function by forward by 1 plus forward plus the loop. Okay, so that would become that P by E. And once that has become, once that has done, then you can keep that as a loop there and write, again simplify the remaining. Is that clear now? Everyone,
Yes. Yes, sir.
Bhavya, Hemant, Deepak, Ishika, Sujit. It's just a, what you call, demazing a maze. That's it. It's a, what you call, it's more of a cat type question than a process control type question. But I think it's a very interesting problem. So that the key aspect is you unclutter the loop one by one.
Sir, if I simplify this diagram, then I don't think so. E should be E. There should be some another variable that we should use.
I did not get you, Hemant, right?
Sir, we have simplified this, right? So after the first comparator, I don't think so. There should be E. We should
should be
name some another variable.
okay. So see, that's what the point. So go up, little bit. Let's go to the so keep zoom out in such a way that let's have the two block diagram as visible to the screen. Now only the, the smaller the second one is seen, but we should be able to see both. Make maybe 100% zoom and just scroll up little bit. For are you there?
Hello, any doubts?
No, no. What I am trying to say is just scroll up and let's have the two both the block diagrams on the same page. Keep it there. Okay, so now to answer Hemant's question, it has so my answer is it has to be E only. Why? Because we have not changed anything. We have only sequenced it. So if you look at what is going inside E prime now, it is E minus y1 tilde plus y2 tilde. Agreed or what?
Sir, E prime is okay, but if I compare both E, in the first case, E is YSP minus Y minus Y2 prime. And in
Okay.
second case, it is YSP minus Y. The both are not same.
In second case, it is no no. In the second case, it is E is YSP minus
Y.
YSP minus Y. Okay. In the first case, it is Y.
YSP minus Y plus Y2 prime.
So
So
now
both
what
are
is it?
not same. So
Okay. So
I'm
now
just
you're
saying we should rename this variable. It should not be the same variable as it is in the upper diagram.
and E in both in the top case, in the top diagram we have written E, in the bottom case we have written E, and you are saying it should not be E. Is that's what you are saying, right?
Yes, sir. I'm saying we should rename it actually with another variable.
Your point is well taken. This has to be some E1 or something because anyway y2 tilde is not subtracted. It's from the original signal. Correct?
Yes, sir.
So Ishika, Stuti, Vistuta, so please pay attention. So I'm saying this is a sample problem. So you would get different types of this. You can have a loop in somewhere else. So the key aspect is try to declutter point by point. You declutter at one point, simplify it and make it a nice loop and simplify it using Mason's gain formula. Then you simplify the next level and finally simplify the whole loop. Okay, guys? Any confusion here? I really want you to internalize this course. Shall we go ahead?
Yes, sir.
Okay. Yeah, Abar, you can go to speak
Yeah,
maybe.
sure. So moving on to the next question. You can try this question. So to find the values in a to make a closed stable loop, you just have to find the perfect values of kz in a or you have to apply the stability criteria in a characteristic equation. So try to make a characteristic equation and apply some stability criteria in that.
Okay. So just to add, thanks Abbar. Just to add, so see, we have okay. So the as Abbar indicated, the question here is to find the value of Kc that makes the system stable. Okay, and he also rightly pointed out that you have to look at the characteristic equation. You have to again declutter the loop, make it as a single transfer function, and look at the characteristic polynomial and see what is happening. Okay, so one thing we have not fully covered in the class, but I'm going to do it in the same thing. We told about a root array technique to check if the polynomials are not really. So if it is a first order polynomial, you can calculate the root. Second order, you may be. If it is higher order polynomial, it may not be easy for you to calculate the roots of the polynomial to check whether the roots are lying in the left hand side or right hand side and so on and so forth. So we have to apply the technique which is known as route array. I think Abar would explain that. So before doing that, you please calculate the characteristic equation. Then we will explain you. So maybe In another 5 minutes, you guys simplify it to calculate the characteristic equation, and remaining 5 minutes, we will explain how to calculate, how to really look at the root and its what we call really look at the root and whether how to calculate that. Okay, so maybe we'll 5 minutes, 1:43 will some we can discuss about. Okay.
Yeah, sure. Okay, so shall I discuss the solution?
Yes, go ahead. Okay.
Yeah. So you all must have formed the characteristic equation for this transfer block. So let me just tell you. So we have to find the characteristic equation for this transfer block. Then we can apply the stability criterion as per the equation. So first we'll multiply all the it is 1 plus GOL, which is multiplication of all these blocks, which is written over here. Then after simplification, we get this equation, and finally a cubic equation. Now for stability criterion, you all know that all the coefficient must be positive. So that's a one condition, but it is not the sufficient condition to tell if the loop is or it is stable or not. So the next is this Rouse stability criterion. It is a theorem, or it is a method to find out if our
Just a
system is
second.
stable or not. So to calculate,
Barabar,
so yeah,
barabar. Just a second. So before, if you just hold, so let me share my screen for a minute. Okay. It has not been explained in the detail in the class. So let me explain
yes,
this. Okay, so as I told, if it is a simple polynomial, you can see my screen, all of you.
yes, sir, yes, sir.
Yes, sir.
Okay, so if it is a simple polynomial, it is not at all difficult for you to find out the root for it, like for first order, second order, so on and so forth. But if this S power has become high, like let's say 3, 4, and all, okay, it may not be easy for you to come up with. It may not be easy for you to come up with this calculating the root. So we have to apply. Now this again is nothing serious about it. It's just a more an algorithmic thing that to check the whether things are okay or not okay. Okay. So first thing you have to check all the coefficients of this polynomial are positive. Okay. If it is positive, so what you call that is something known as the necessary condition. So you have to check if it is at least one of these coefficients of this are negative, then we could stop checking further. Then at least there is a chance that root can go into the RSS domain. If you find all of them are positive, you have to make something known as a route array. So route array is make it's just a table. Okay. So let's say if this is your polynomial a n a raised to n a n minus 1 a raised to x plus minus 1 till a1 x plus a not divisible 0. Let this be your polynomial. The root array, how do you make? So an minus 1, 1 below. An minus 2, n minus 2. It's like that you write. So if there are three coefficients, it would be, so let's say it is 3. So it is an, a minus 1, and an minus 2. An minus 1, an minus 2. Here it will be 0. So now what you have to do is, so now you have to reduce. So you have to come up with, you have to make, if there are n is the order of the polynomial, you have to make n minus 1 rows you have to construct. Again, fairly easy. So first row, uh, so you have to keep this base. So how to calculate B1 here? So B1 would be an minus 1 into an minus 2 minus an into an minus. So an into n minus 3 divided by an minus 1. So that you will get B1. B2. B2 would be again, you have to keep the base row constant. An minus 1 into an minus 4. You see? Again, an into n minus 5 divided by n minus 1, so on and so forth. So you will get here the row of B. From B, you calculate C. How do you calculate C now? C is B1 into n minus 3, okay, minus an minus 1 into B minus 2 divided by B1. Okay, how to calculate C2, which is belongs to this? So again, B1 into n minus 5, okay, n minus 1 into B3 divided by B1. So like that you construct this small coefficient below and below until you make n minus 1 rows out of it, where n is the order of the polynomial. If all of this left hand side column is positive, okay, then your test is successful. Which means that all the necessary and sufficient conditions for negative root is the checking of all of this becomes all of this left hand side, this thing becomes positive. Is there any confusion on this? This is there in the note. I think I have uploaded the note, so you can keep it side by side. Okay, this is as equivalent as checking the root, computing the root of it, and checking whether they are positive or negative. Because this is easier to perform than that other one you would require solving it. But here you don't have to solve it. You have to just do some rearrangement and check whether the newly constructed variables are positive or negative. How they are matching, there is a theorem which we don't want to study. So now what you can do is, let me just unshare and Apar can share.
Yeah.
Keep your root thing on the side by side, okay?
Yes, sir.
Okay, so now, uh, uh, yes. So now you start making the, so yeah, so you can start the route array solutions now. How are you getting it, the terms? Yeah, so you start, so it is a cubic order polynomial. You may be still be able to solve it manually, but I think let's use the route array, which is an easier exercise, okay? Yeah, go ahead.
Yeah, so we got this equation, which is the characteristic equation for this system. Now, to calculate the route array, the first two rows are the coefficients, which is the first, third, and second, fourth. As you can see, 135, 14, and 4kc minus 50. Now, we need to the next term is B1. Now, to calculate it, we need to multiply 14 into 35 minus 1 into 4kc minus 50 divided by 14. This is our B1 term. Now, C1 would be similar to this. It would be B1 multiplied by this term, and oh sorry, this multiplied by this minus this 0. So we get the 4kc minus 50 term. Now, for route array or to be system for a system to be stable, all these left hand side terms must be greater than 0. So this term must be greater than 0, and this term must also be greater than 0. By putting these terms greater than 0, we can find the condition for our system to be stable, where we can find the range for the value for Kc, where our system could be stable. So any doubt on that?
Okay, so you have to also look, see, so this is a third degree polynomial, so you have to make 4 rows. Huh? First
Yeah.
few rows anyway already written. See 1, 40, 35, 40 minus 4kc minus 50. So now look at the first, which is the B1 thing. So how do you calculate the B1? So B1 would be as Abar explained to us, 14 into 35 minus 1 into 4kc minus 14, because there is nothing here. Here the third column is 0, 0, so you cannot proceed further. So now look at the C1. So you now go to your B1. From now, how calculate B1 to C1? So again, apply the same procedure. So you would see that uh, nothing remains, only the 4kc minus 50. So, so now what we all need is all your left hand side column coefficient has to be positive. 1 is of course positive, 40 is 14 is of course positive. So now 4kc minus 50 has to be positive, 490 minus 4kc minus 50 by 14 also has to be positive. So once you keep that, once you rearrange that, your problem is done. Is that okay?
Yeah, any doubt in that problem?
See, please try yourself on. It is not difficult. It's just making that table as per prescribed and looking at the first column of all the variables to be greater than 0. Cool? All of you? Any issues?
Yes, sir.
Apar, Bhavya, Deepak, Hemant, Isika, Nikita, Sudhi, Vishnuta. All clear?
Yes, sir.
Okay, so now we have only 7 minutes left. So let me just check which question we could go on. So give me a minute. So let me look at the next question. Okay, so let's do the next question. That is also reasonably. Also, maybe you can take the time till 157 or 158. Again, steps are the same. You see,
Yeah,
simplify the block diagram, apply the closed loop condition. So look at the third question, but in the middle somebody asked me.
yeah. This is the combination of above two problems. So just try to do it.
As Abar pointed out correctly, this is like a mix of 1 plus 2. So there is some juggler you have to make to simplify and of course apply the rest. But it's fairly simpler compared to the case one.
All
Okay.
right. So the
Yes.
question, yeah, is a combination of the above two questions. First, we have to find the closed transfer loop function of y and d, which is the output and the disturbance, and then we will need to find the value of kc in which our closed loop system would be stable with these values. Now, so first we will need to find the closed loop transfer function. So there is no diagram, so I will try to be as specific as I can. Okay. So what we have done is we have divided the y in y3 plus y2, which is coming from here. Then we calculated what is y3 and what is y2 by going backwards, basically, right? To find what is the value of d, we go backwards till we find the value of till we find all the terms in terms of YSK. So y is equals to y3 and y2. Y3 we wrote it as g3z, where z is d plus y1. As you can see, uh, it is d plus y1 into g3 is equals to y3, and y2 can be equals to p into g2, right? Uh, yeah, g2 into p. Now, to calculate what is p, we knew that p is equals to kc into e from here, and then we calculated what is the value of e from this block diagram and what is the value of y dash p. Now, simplifying this, we came to this equation. Then, taking d in common, we can find the transfer loop function. We are just going backwards from here, calculating every step what is the value for every output, and in the end we only are left with y, d, various other function kc and km. So any problem in this? Any doubt you have?
Yes, thanks, Sapar. So just wanted to say again, so you have to just look what you want to relate. You have to relate between y and d. Okay, so because the question asks you to derive between y and d, so you will have to bring out all the terms in such a way that y and d are connected. So first of
Mhm.
all, y you write fair enough, y3 plus y2, and afterwards you would tend to write what is y3 and y2. Okay, so when you start writing y3, you see that there is d comes into the picture. So now you further expand. Okay, so all this exogenous variable has to be, endogenous variable has to be gone. Only the exogenous variable, which means the endpoint should be there. So E is an endpoint. Okay, similarly, so even E also you remove. So finally, you simplify it one by one. So D is there. So now E has come. So E you write again as the difference between S by ST minus whatever. So Km times Ym. So you keep on decreasing, decreasing, decreasing until now your y has only endogenous variable, which essentially means that only the variable that is outside the loop. So you look at this expression that contains y, d, and y. So it's all in the exogenous variable. So now you kind of rearrange and get y by d. Okay. So now after that is done again, so just to quickly wind up, you have to look at the characteristic equation. So
Yep.
the characteristic equation is 1 plus
So,
this.
yeah, yes, sir, continue.
Go ahead, go ahead. Yeah, you can continue.
Yeah. So, in similarly, we'll find the characteristic equation for this. And after finding the characteristic equation, we know that it is a quadratic equation. So, no need to find the Routh stability criteria. We can see that all the coefficient must be positive. As we know that in even in the Routh stability criteria, the first two rows are for the coefficient. We can say that 14 kc minus 1 and kc minus 1 should be positive, and we can say that for the stability kc must be greater than 1. It is a simplification of the characteristic equation. We find that it is a quadratic equation, and we can just put the quadratic equation's coefficient positive for the stability criteria. This is the only conditions you require to make the closed loop stable in this system.
All of you are around. So just one simple point here I wanted to say some. So you might have seen. So just go up a little bit.
Yeah.
So just again, just take a close look. So here it is written E is equal to minus Km times Y. So one confusion that you would have where the YSP has gone. Anybody has that doubt? So YSP should be YSP minus E. No? Where the YSP has gone? Can someone say? Okay, so please mind that we are making a regulator transfer function y by d. Okay, so you have seen servo and regulator. The servo problem, we will have the YSP value to be put as it is, while in the regulator problem, as we have discussed in the class, okay, you keep YSP to be 0 because you have been asked to find Y by D, which essentially means that we are calculating the regulator function. So there is no role of YSP over there. So that is why E is equal to YSP minus Km times Ym, where YSP is 0. So 0 minus Km times Ym, that is why minus Km times Y. Please mind it, but if you are asked to find Ys by YSP, you should write what E is equal to Y minus YSP. Is that clear? Since we are calculating Y by D, this has become 0. Cool? Any issues here?
No, sir.
Okay, so in the last question, maybe you can just show the question and we can stop. We don't explain it. So
Yeah.
again, yeah, go ahead.
So here we are given a transfer function, and we need to find the range of controller settings that we have already done. Like what is the settings to for a closed stable loop system. But here our systems are a proportional controller, a proportional integral controller, and the last is if we just increase the integral controller in this system, what will be the effect? So to solve this, just write what are the equations or what are the transfer functions for both of these. Then try to apply the characteristic equation and like if I may show the solution a bit. Just try to apply the stability requirements we have already discussed. What may be the stability requirements here, and try to find a reason why on what effect our integral controller has on the total system by comparing both the stability criterions or what the stability requirements we get after these uh, let's say conditions applied.
Okay, so just to add, so here the simplified question says, just project it,
Yeah, sure.
a question. So only the question.
Okay, only the question. Yeah.
So see, you're only saying there is a process and you have a controller. Controller you have to write, but it is said that all other transfer functions are 1. So please put that again, simplify it and do this. Okay. So I think that's all about this particular uh, tube. Okay. If you have any issues, we can resolve it in the coming classes. But I think take home messages, learn how to simplify the loop, okay, and how to apply the route at the stability criteria. If it is a higher order polynomial, to check the stability. Otherwise, again, if it is a smaller first order, second order, you may be able to solve it directly. So that's all about the key take home message. Look at some problems in the textbook, try to solve yourself. If you have some issues, please get back to us. And that's all about any other issues, guys. About is always there. Bhavya, Deepak, Heman, Nikita, and Suti. Are we okay?
Yes, sir.
Yes, sir.
Yeah, if you
Okay,
have any problem, you can contact me on Teams as well.
perfect. So thanks, guys. Thanks, Apar and all other participants. Let's close the session. Bye.
Yeah.